Welcome to this short session of research presentations. Here, deputizing for Dr. Craig because he has some other things to attend to. He says he will just be coming back and forth, back and forth. So, I'm being told we have 4 hours here, but I guess with the, what's this now? With the submission of thesis and the ones to be presented by the mathematics students, I don't think we will last more than 1 hour, 1 hour, 30 minutes here. The earlier the better, actually, so we can get to do some other things. So, if you are you set now? So I call the first group, or you're still? Our call is by the name Flores Mary Grace, and the topic to be presented is Crystal-Wallis test. Just flow along, and if you don't understand, those who are not mathematics students, just because I know you may not be able to relate. All right? So if you're set, we'll have you. Please, a round of applause for
All right, so good afternoon, everyone. So I was already introduced, so I will be presenting one of the statistical tools to be used in doing research. So that's the Crystal-Wallis test. So in doing research, one of the most important things that we will need to consider is what statistical tool do we need to use, depending on the data or the kind of data that we will gather rather, and also depending on how we will interpret and how we will draw our conclusion from the statistical tool that we will use. So today I will present about the Crystal-Wallis test. So first thing, what is Crystal-Wallis test? So Crystal-Wallis, which is also can be called as H test, because basically the value of Crystal-Wallis is represented by the letter or capital letter H, or sometimes called the one-way ANOVA on ranks. Why one-way ANOVA on ranks? Because ANOVA is the parametric test of Crystal-Wallis, or on the Crystal-Wallis, because Crystal-Wallis is the non-parametric test. How do we say non-parametric test? How do we differentiate non-parametric from parametric? Is that non-parametric do not assume a normal distribution, while a parametric test assume normal distribution. And also, one of the biggest difference between non-parametric test and parametric test is that non-parametric test uses ordinal data. So when we say ordinal data, we use this rating scale most of the time, or we will use ranks. That is the reason why it is called one-way ANOVA on ranks, because it's a type of ANOVA. It is something similar to ANOVA, but we will rank the data, or we will have the data on rating scale. So it's a rank-based non-parametric test, as what I told you a while ago, that can be used to determine if there are statistically significant differences between 2 or more groups of an independent variable on a continuous or ordinal dependent variable. So ordinal data rating scale. So one of the example for this is just like you will, just like how you will evaluate our teachers when you are given an evaluation form by the dean's office, like 5 is very satisfactory, 4 satisfactory, fairly satisfactory. Those are an example of an ordinal data. That is a Likert scale, or you rate the data. So next is it is considered the non-parametric alternative to the one-way ANOVA and an extension of the Mann-Whitney U test. An extension of Mann-Whitney U test because Mann-Whitney only tests the significant difference between 2 groups. While when we say Crystal-Wallis, we test the significant difference of 3 or more groups of data. Okay, to allow the comparison of more than 2 independent groups. So when we say significant difference, that means true in the sample, because basically on research you do not really usually do not test the entire population, like the entire NORSU students. You will not test all of that because it will be time consuming. So that means you will just get a sample size, and it should be randomly selected. You do not just have to choose. I want this to be the respondent, her to be the respondent. There should be a randomization, and also significant difference. So that means if and the sample size, the result is like this. That means it is also the result of the entire population. True in the sample and then true in the population also. Okay, so this time we will actually present a specific, just a simple problem that we can have that we will involve using Kruskal-Wallis test. So the statistical problem that I will be having is this. This research uses data that was taken from the customer satisfaction surveys from a school canteen in NORSU. Customers were surveyed to choose those attributes they think are important when considering services from the canteen. I actually think of this idea because a lot of students I may not know them, or I may know them. Actually, somewhat like complain some of our stalls and some of the services of our canteen. So I would like to know if some of their attributes, or if there is a significant difference between the attributes. Okay, so they said that the most important attributes this canteen could provide to meet their needs and generate high levels of satisfaction are. So this is now the group of data that we will be having. So the respondents rate the services or the attributes of the canteen is this: courtesy, how courteous are the service crew in the canteen or our staff in the canteen, scheduling a convenient time for service, arriving with promise to perform the service, meeting customer expectations, being neat and clean, answering questions about the service when asked, competitive pricing, quality of the food products, and providing overall value. So as you see, we have more than three groups of data. We have 2, 4, 6, 8, 9. Next. So based on my collected data, so this is now the table 1.4. This is the table of the data gathered. Okay, so we have courtesy, scheduling, arriving with promise, meeting customers. So this is actually on the rating scale from 1 to 10. 1 being extremely dissatisfied and 10 being exceeded my expectations. So we use rating scales. Okay, so we will know the literature about Kruskal-Wallis. So what is the Kruskal-Wallis all about? So the Kruskal-Wallis test, when you have one nominal variable and one ranked variable. So if in case you don't have a rating scale kind of data, like you will have nominal data, you will have to rank them so that you can use Kruskal-Wallis test. So when to use it? I already informed you a while ago about that. We will use it when you test the significant difference between 3 or more groups and uses an ordinal data that we assume no normal distribution. Okay, so that's the assumption, not normally distributed. So, next, that's just the same thing. Okay, so now, when you have a problem, of course, we always have a tentative answer to your problem. We have that in research. So the statistical problem now, we have the null hypothesis and the alternative hypothesis. So we have a claim, meaning the tentative answer to your problem. That is, there is no significant difference among the satisfaction scores of any of the attributes that are important when considering services from a school canteen. So that means all of those attributes actually have the same satisfaction scores or satisfaction scores based on the survey conducted. So that is our claim. So always remember, if you have this kind of data, you always have your null hypothesis. Usually there is a no. So there is no significant difference. So that will be our HO or the null hypothesis, which is also our claim. So when we have a null hypothesis, we will always take a look into its alternative hypothesis, meaning its opposite. So when we say there is no, basically the alternative hypothesis will be there is. There is a significant difference among the satisfaction scores of any of the attributes that are important when considering services from a school canteen. Alright, justification. Why do we say so? And why do we use Kruskal-Wallis test? So basically, we use Oldener data, the Likert scale as what I told you a while ago. So that's one important thing that we need to consider when choosing which statistical tool you will use. And then, we had more than 2 independent groups. So that's courtesy and the rest. Okay, so we compare the different samples and to calculate whether they are statistically significant. There is a significant difference between those attributes. Okay, so here is now the presentation of the data. After you choose what statistical tool you will need to use, it is now time for you to present the data based on the result. So normally I got this data because since we have now our modern technology, we don't need to manually compute the values. So we use Megastat in Microsoft Excel. So we have these groups and then the median on the rating scores or satisfaction scores, average rank, then the H value or the Kruskal-Wallis test value, the p-value, the decision, and interpretation. So in interpreting the data, the only value that we will need to look is actually the p-value. And the p-value there is 0.3468. So actually this is at 5% level of significance. So when we say 5% of significance, this is actually the percent when we can have a type 1 error in statistics. So therefore, we can say that the p, always remember that when the p-value is greater than your level of significance, so when we say 5%, that means 0.05. And we can say that 0.3468 is greater than 0.05. Then we can accept HO. Now, if the p-value is less than or equal to the level of significance, then we have to reject our HO. Okay? So that means not significant. Our interpretation is not significant. Our claim is HO. So therefore, our interpretation will be at the 5% level of significance, there is not enough evidence to reject the claim. Our claim is HO, we accept it, therefore there is not enough evidence to reject it. That there is no significant difference between the satisfaction scores of any of the attributes. Okay, so we will now have the result. So since the p-value is equal to 0.3468, which is again greater than the level of significance, or denoted by the letter A, 0.05, or that's an alpha also, so we accepted HO. Thus, we accepted that there is really no significant difference among the satisfaction scores of any of the attributes that are important when considering services from a school canteen. So hence, based on the result, we can say that the satisfaction scores of any attributes that are important when considering services from the canteen are most likely equal or the same. So one of the very important things when you will have your research or when you will code something, you will need to have your reference or you will need to cite, you will have in-text citation. So this is also to avoid plagiarism. Okay, so the references here are based on the APA format. It can be found in Microsoft Word. That's actually mostly what is used right now. Okay, so the last one is the appendices. So basically, these are the data I have when I input it in the Microsoft Excel. And this is the result. And this is the result when you run it through Megastat. So you just have to input the data, you have to do Megastat, run it through, and then you will have that result. All you have to do is to interpret it. As easy as that. Okay, so in appendices we need to have a documentation or an evidence of gathering data. So that was it. These were the students, and these were the satisfaction scores. And lastly, this is how I gathered my data. I have these questions. Basically, they have the sample questionnaire. Okay, so the instruction is, please rate how satisfied are you on the services of our school canteen on a scale of 1 to 10, with 1 being extremely dissatisfied and 10 being exceeded my expectations. In terms of, so was everyone courteous? Did you schedule a time that was convenient for you? Did the orders arrive on time? Did you meet your expectations? Did we leave your facility neat and clean? Did we answer any questions that you had? Was our price competitive? Please rate the quality of our products and services. And do you believe you received a good value? So those are just our groups of data turned into questions for us to have a questionnaire. So this questionnaire is the questionnaire I let my respondents answer to. So that's it.